Hello everyone, welcome to Maths Bridge. UML building blocks, diagrams used in UML. Let's get started. In today's agenda, we shall walk through UML diagrams, structural diagrams, behavioral diagrams, 5 views of the system, rules of UML, UML driven process, work products, development process. Let's get into more details. In today's session, we will see UML diagrams, which are part of UML building blocks in conceptual UML model. UML diagrams. Basically, UML diagrams of two types, structural diagrams and behavioral diagrams. Structural diagrams depict the components that make up a system and the relationship between those components. These diagrams shows a static aspect of the system. We have classes, components, objects, composite, deployment and package are a static diagrams. Static aspect of a system is what it represents. On the other hand, we have a behavioral diagrams. Behavioral diagrams represents what happens within a system. They show how all components interact with each other and with other systems or users. We have activity diagrams, state machine diagrams, use case diagrams, interaction diagrams. If you look at closely in interaction, we have a communication, interaction, sequence, and timing. Use case diagrams, static structure diagram, behavioral diagrams, state chart and then activity would be a behavioral at high level classification, sequence and collaboration under interaction, component deployment under implementation. We can represent the way you see the system, but in broadly we will talk about, or we are going forward, we will mostly representing like structural diagrams and the behavioral diagrams. Interaction diagrams, sometimes we represent a part of the behavioral diagrams, or sometimes we can also make it a separate entity like a structural, behavioral and interaction. UML diagram snapshot. You can see here use case diagram, class diagrams, activity diagrams, state machine diagram, sequence diagrams, package diagrams, composite diagram, component diagram, and deployment diagrams. These are the few examples, but you can see many more in the real time. A class diagram shows a set of classes, interfaces, and collaboration, their relationships. Class diagrams that involves active classes addresses the static process view of the system. On the other hand, object diagrams represent a static snapshot of an instance of the things found in a class diagrams. These diagrams addresses the static design view or static process view of a system. An object diagram shows a set of objects and then relationships. Let's talk about use case diagrams and sequence diagrams. Use case diagram shows a set of use cases, actors, and their relationships. Look at this. All the ellipse, oval symbols, right, are the use cases, are defined within the system. This is a boundary. These are the actors which are interacting with the system using these for these use cases. Use case diagram addresses the static use case view of the system. These diagrams are especially important in organizing and modeling the behavior of the system. Both sequence diagrams and collaboration diagrams are kind of interaction diagrams. Interaction diagrams addresses a dynamic view of the system. Sequence diagram is an interaction diagram that emphasizes a time ordering of messages. Collaboration diagram is an interaction diagram that emphasizes the structural organization of the objects that sends and receive the messages. Sequence diagrams and collaboration diagrams are isomorphic, meaning that you can take one and transfer it to another. State machine diagram. State chart diagram shows a state machine consists of states, transitions, events, and activities. State chart diagrams addresses a dynamic view of a system. They are especially important in modeling the behavior of interfaces, classes, or collaborations, and emphasize the event-ordered behavior of an object. An activity diagram is a special kind of a state chart diagram that shows the flow of an activities to activity within a system. Activity diagram addresses the dynamic view of a system. They are especially important in modeling the function of a system and emphasize the flow of control among the objects. Component diagram. Component diagram shows the organization and dependency among the set of components. Component diagram addresses a static implementation view of the system. They are related to the class diagrams in that a component typically maps to one or more classes, interfaces, and collaboration. On the other hand, a deployment diagram shows the configuration of a runtime processing nodes and components that live on them. A deployment diagram addresses the static deployment view of the architecture. Look at, for example, five views of the system. Sometimes we call it as a 4+1 views of the system too. The user's view captures the external user's view of the system in terms of a functionality offered by the system. The user's view is a black box view of the system where the internal structures, dynamic behavior of a different system components, the implementation, etc. are not visible. We have user view, structural view, behavioral view, implementation view, and environmental view. A structural view defines a kind of objects like a classes important to the understanding of a working of a system and to its implementation. It also captures the relationship among the classes. We have a class diagram and object diagram under structural view. Look at the behavioral view. Sequence diagram, collaboration diagram, state chart diagram, activity diagram, mainly under behavioral view. A behavioral view captures how objects interact with each other to realize the system behavior. The system behavior captures the time-dependent behavior of the system. What does it mean, implementation view? Implementation view captures the important component of a system and the dependencies. Component diagram under implementation view. Coming to environmental view. A deployment diagram basically deals with the environmental. This view models how the different components are implemented on different pieces of an hardware. That's why this is called a 5 view of the system. Rules of UML. We have names, scope, visibility, integrity, and execution. Names. What you can call things, relationships and diagram. You name them properly. Scope. The context that gives a specific meaning to a name. Visibility. How these names can be seen and used by others. Integrity. How things properly and consistently relate to one another. Execution. What it means to run or simulate a dynamic model. These are the rules of UML in case of modeling. In software development lifecycle, across all phases, we can easily see UML plays a vital role. If you look at from the requirement to implementation, one way or other, we have a supported UML diagrams to represent the each phase of the SDLC. Let's say in the requirement phase, we use case diagrams. During the detailed analysis phase, we use use case diagrams and object diagrams. For consolidating in specifications of a system, we use object diagrams, sequence diagrams, and class diagrams. During the design, we need to have a class diagrams, sequence diagrams, state chart diagrams. During the implementation, you have a state diagrams and deployment diagrams. So likewise, we can map all UML diagrams for each and every phase of SDLC lifecycle. Working products. Let's look at various models and what sort of diagrams we use in each model. For functional modeling, we use use case diagrams. For analysis object model, simple objects and class diagrams is what we use. For dynamic modeling, we use a state and sequence diagrams. Object design model, we use a class diagrams. For implementation model, we have a deployment and activity diagrams. Let's look at how UML will be leveraged during the development process. During the requirement elicitation phase, what we do is like we use use case diagrams to gather the requirement at high level. Then we started identifying the major objects and their relationships, make use of objects and class diagrams. Create a scenarios of use cases using class diagram, sequence diagram, collaboration diagrams. Once we have the scenarios, we generalize the scenarios to describe the behavior of the system. Make use of classes, states, and activity diagrams. Then what we should do, refine and add implementation details more. What we use here, component and deployment diagrams. Likewise, UML modeling is helping us in software development lifecycle in designing a system.
Thanks for watching. Please like, share, subscribe, click on the bell icon and please leave the comment. Happy learning. Thank you. Stay tuned to the upcoming sessions.